Hello future engineers, subscribers, viewers, and students. Here is another video in integral calculus, particularly on computing the work required to pump out water or any liquid to the spout or to the outlet. I hope that through this video, your skills and knowledge in calculus will be enhanced, not only in calculus, but also in mathematics as a whole. So here is the first problem, 35A. A tank containing water is in the shape of a frustum of a cone 12 feet across the top, 6 feet across the bottom, and 8 feet high. It is full of water. So A, determine the work required to pump water out of the spout. B, determine the work required to pump the upper 4 feet deep water out of the spout. The spout is at the top level as shown in this figure. That's the spout. So for the solution, 6 feet across the bottom, 12 feet across the top, so meaning the radius of the circular section at the top is 6 feet, at the bottom 3 feet. So we have this extension here. I call this h. Let's solve for h. Then the radius of the slice, or this here, is in general x. Distance from the bottom of the tank to that level is y, then thickness of the slice dy. Distance of the center of gravity of that slice to the spout is 8 minus y, height minus y. So by similar triangles, h as to 3 or or h as to 3 equals h plus 8 as to 6. So solving for h is equal to 8 feet. So that if we call this x as to, this is x as to y plus y plus 8 equals 3 as to 8, or 3 as to 8. So x is 3/8 of y plus 8. So again, x is 3/8 of y plus 8. So work is equal to integral of specific weight of water 62.4 times differential volume of this slice. The volume of this slice is pi x squared dy, and the distance of the center of gravity to the point of disposal to the spout is 8 minus y. So work equals, so 35A work equals integral from 0 to 8 of 62.4. The differential volume is pi x squared dy, then distance of center of gravity to the point to the spout is 8 minus y. Replacing x by 3/8 of y plus 8, so that would be 62.4 pi integral 0 to 8 of x squared is 9 over 64 y plus 8 squared, 8 minus y dy. You can expand and evaluate the integral by power formula, but since this is an easy integral to evaluate, I'll just use the calculator. So work is equal to 103,507 pound-foot. You have to verify that. Then the other way is, since I derived the formula for the distance of the centroid of this volume cone, the volume of the cone is pi h over 3, quantity big radius square plus small radius square, big radius square plus big radius small radius, big R small r plus small radius square. That's the volume pi h over 3, quantity big R square plus big R plus small r square. While the distance of the center of gravity or centroid from the smaller end, smaller radius, is equal to height, quantity 3 big R square plus 2 big R plus small r square over 4, quantity big R square plus big R plus small r square. So this is again h times quantity 3 big R square plus 2 big R small r plus small r square over 4 quantity big R square plus big R small r plus r square. So take note that the denominator is the other factor for the volume, pi height over 3, then times this. And this is, the numerator is arranged in the same manner as the numerator, as the denominator rather, but it is of decreasing coefficient, so 3, 2, 1, so that you can easily remember this. So pi h, pi height over 3 times this factor here is the volume. Also take note that this distance gives us, when small r is 0, this becomes a cone, and this gives us 3/4 of the height. 3r square over 4r square is 3/4 of the height, which is the distance from the vertex to the centroid of the cone, if it is a cone when small r is 0. So that formula is correct. You just look at the derivation which I uploaded in statics. So substituting, height is 8, then quantity 3 times 6 square plus 2 times 6 times 3 plus 3 square all over 4 quantity 6 square plus 6 times 3 plus 3 square, and that is equal to 34 over 7 feet. So having found the distance from bottom to that, so the distance of centroid to the spout is this. It is equal to 8 feet minus 34 over 7. So the alternate solution is work equals 62.4 times volume of frustum of a cone, which is pi height over 3 quantity big R square plus big R small r plus R square. So 62.4 pi times height, or height 8 over 3, quantity big radius square 6 square plus small radius 3 square, then plus big radius small radius. Then distance from center of gravity to spout is 8 minus this distance. So calculating, it is also 103,507 pound-foot. Then for part B, determine the work required to pump the upper 4 feet deep water out of the spout. So the upper 4 feet. So we can still use this technique. This time the height is 4 feet. By integration, we use the same expression. We just change limits from 4 to 8. So work 62.4 pi integral 4 to 8 of 9 over 64 quantity y plus 8 square quantity 8 minus y dy. So using your calculator, work is 39,403 pound-foot. And using the direct way, let's locate the center of gravity first. So this is now the upper half. So imagine this is ignored, the lower 4 feet deep. So height is 4 feet. The distance from the bottom is same formula, but the smaller radius this time is, because it is 4 feet, half of 8. So it should be the average of 3 and 6 feet, which is 4.5. So therefore, this distance would be 4 quantity 3 times 6 square plus 2 times 6 times 4.5 plus 4.5 square all over 4 quantity 6 square plus 6 times 4.5 plus 4.5 square. And that is equal to 81 over 37 feet. So substitute, the volume this time is pi times 4 over 3, pi h over 3, pi 4 over 3, then quantity 6 square plus 6 times 4.5 plus 4.5 square. So work is 62.4 times pi times height 4 over 3, quantity 6 square plus 6 times 4.5 plus 4.5 square. Then the distance is now 4, because this is 81 over 37. So distance to the spout of the center of gravity would be 4 feet minus 81 over 37. And it should also be 39,403 pound-foot. For problem 35B, let's have that on the next slide. So 35B, The tank has triangular section. So a tank has a section that is in the shape of a triangle, 12 feet across the top, 6 feet deep, and 10 feet perpendicular to the triangular section. It is full of water, so determine the work required to pump A, all the water out of the spout. The spout is at the top of the section. The upper Determine the upper 3 feet deep of water out of the spout. So this is the shape. So this is our slice or slab. Distance from bottom y, and that is also x because this is constant 10 feet perpendicular to the screen or to the triangular section. Then area S is 10x, where x can be expressed in terms of y by similar triangles. X as to y equals 12 feet as to 6 feet because that's 6 feet. So x as to y equals 12 as to 6. So that means x is 2y. Then work integral from 0 to 6. So first part is we have to find the work done in pumping all the water out of the spout. The spout is here at the top edge level. So distance of center of gravity of this slice to the spout is 6 minus y. The depth minus this height y. So work equals specific weight of water 62.4 times differential volume area S dy 10x dy, then distance 6 minus y. So replacing x by 2y, work equals 624 integral of 2y quantity 6 minus y dy. Again, this is an easy integrand to evaluate. I leave that to you. Check that the work done is equal to 44,928 pound-foot. Then for the second solution, uh, 62.4 times volume. The volume is area of this triangle times 10 feet. And the distance of the centroid is, of course, 1/3 of 6. So 2 feet centroid of this triangular wedge. So it is also 1/3 of 6 feet. So alternate solution, 62.4 times volume, which is 1/2 of 12 times 6 times 10. Then distance from center of gravity to the spout is 1/3 of 6 or 2 feet. 62.4 volume is area of this triangular section, which is 1/2 of 12 times 6, then perpendicular to the screen 10 feet. So that's the volume 62.4. So that's the weight of total weight of water inside the tank. Then distance of center of gravity of volume to the top 2 feet. So work is also 44,928 pound-foot. Then finally for the upper half, we use this integral. We change limits from 0 to 6 to 3 to 6. So 3 to 6, that's an easy integrand. So I leave the manual or uh, manual way of evaluating that integral. I'll just put the answer 22,464 pound-foot. For the alternate solution, let's do this section here. So if we consider the upper 3 feet, so this is trapezoidal in section, and this trapezoidal section will be divided into two parts, rectangular and triangular. For the triangular part, it should be 6 feet because that's 3 feet, half of 6 feet. So the dimensions will also be halves. So 6 feet, half of 12, 6 feet, half of 12. Then 3 feet. So work is equal to 62.4 times volume, which is area of this rectangle, times 10 feet. Then distance of centroid to the spout, this is the spout level, is half of 3, 1.5 feet. So 62.4 volume is 6 feet times 3 feet times perpendicular to the board 10 feet. Then distance of center of gravity to the spout half of 3 feet 1.5. Plus for this 62.4 area is 1 half of 6 times 3 times 10. Then distance of center of gravity to the spout is 1/3 of 3, so 1 foot. 62.4, 1 half of 6 times 3 times 10, that's the volume of this part here, then times 1 foot. Calculating, that's also 22,464 pound-foot. So that's it for this video.